Yes, hello there. Welcome to another episode of Amplifying F Sharp. Let's do a quick introduction and get on our way for today. So, what is Amplifying F Sharp? We are an initiative that tries to contribute to the F Sharp ecosystem. Our bread and butter has been live sessions like the one we're doing today about various typical different topics where we dive into all the various open source aspects of F Sharp. So today's session is going to be with Vlad about FSharp.Core.Extended, and then next week we're having Lewis. So definitely check out. If you have interest in being a participant or driving a session, you can go to our little join us page. There's a little form over here where we need to know who are you, what time zone are you on, what kind of a topic, and when you were to submit this, if you were to do the whole field, it actually takes you, just put in some stuff here. There we go. What that actually does is it brings you to GitHub. I'm not really signed into GitHub right here. The point I'm trying to make is that you're going to amplifying F sharp. So over here, let's do that. We have a little repository and sessions, and basically the form I just showed you creates an issue over here. And this is where we really sort of pick up the conversation. So if you were to create this kind of issue and by the weird chance that you're not hearing anything from us, do feel free to just poke us again and keep the conversation going. So we have a couple of people that opened an issue, weren't really sure what to do, and then we're sort of trying to have that little chat about what could we go for a certain session. And yeah, just wanted to add today that, talk to us. If you don't hear from us, we're very sorry. We really try and do our best to stay on top of this. But if it doesn't happen, well, just poke us again, and we'll definitely catch you later. And without further ado, I'm just going to give it to Vlad, who's going to talk about FSharp.Core.Extended. Welcome, Vlad.
All right, everyone. I'm Vlad. I used to work in Microsoft and F-Sharp team. I mean, I'm still in Microsoft, but I changed teams recently, but I'm still doing F-Sharp as a kind of hobby and a side project, and because I enjoy it. Today, I'm going to talk to you about a thing which is probably very close to many community members, which is like F-Sharp Core and F-Sharp Core's, let's say, inability to have certain functionality or like certain perf improvements or just kind of limitations. So as some of you know, I'm sharing screen. I'm going to show a bunch of codes. I'm going to show a bunch of NuGet packages and some plans what I'm planning to do with this extended library. But first, so F-Sharp Core is as you can probably infer, it's a core library for the F-Sharp. It contains a bunch of stuff to work with built-in data structures. It has a bunch of stuff around queries, around arrays, around the async tasks, events, and pretty much anything .NET, which with just more F-Sharp friendly wrappers, which are current functions. F-Sharp is unfortunately using some compiler intrinsics, or like rather compiler has intrinsics which are only allowed to F-Sharp. Things like statically optimized functions, when you can sort of overloads a function which for the specific type and provides the different implementation. I know there are people in the community who want to this functionality to be open, but I think as long as Don has anything to say about F-Sharp, I don't think it's happening. So problem of F-Sharp is that F-Sharp Core is that it has to be as compatible as we can. One of the reasons for that is, a bunch of people are using F-Sharp for older frameworks. We ourselves, or F-Sharp team themselves using the F-Sharp for things like Visual Studio extension, which is unfortunately .NET Framework 4.6.2 only when hosting like inside of Visual Studio. So we need to have a F# core with a net standard 2.0. This limits us to certain things we can use, and it limits in a couple of ways. First one is we we only have net standard 2 and 2.1 flavors or target frameworks of the package. We discussed it a bunch of times whether we want to have more, but we decided it's just going to fragment standard library even more. So we're just going to essentially be duplicating like we do now, or like we, it's still a sort of habit. When I say we, I mean like F# team, who is I'm not part of, and the F# community, I suppose. And for now, we have two target frameworks, which we're targeting F# Core for net standard 2.0 to 2.1. The differences between those two are super minimal, but we sacrificing package size for that. So like we have two almost identical copies of FSharp Core DLL, which differ in, correct me if I'm wrong, it's just a bunch of task-related stuff, and making such packages for every single new target framework it's a bit wasteful, given that we have to ship it with SDK, we have to ship it in VS, so just like bloating the size. So in a couple of kind of personal projects, I've been hitting the issues when like I needed more perf or I needed different implementation of certain things. And I decided that I'm just gonna make or try to make a sort of drop-in replacement or addition to the F# Core Extended in a way, where what I've been doing is I've been just going module by module, and whatever I've been hitting a thing which I'm interested in improving, I've been just replacing it with an implementation I would like to. For example, in arrays, I needed an implementation of sum, which would be hardware accelerated, vectorized. So I just wrote it this way. Or we for the enumerables, for the arrays, like I wanted to enumerable min and max for like very specific task to utilize the runtime vectorized or fast version of the this function. I'm saying drop-in replacement, but I don't mean that like you just can download it, like install it, open it, because like it's if you open it, it's just gonna shadow like everything in from the F# core. I'm not saying that it's gonna be behaving one-to-one. I'm still I think I documented some of the discrepancies. For example, the min max are going to be behaving differently when the not the numbers are involved, the nonce are involved. So they're going to just match the BCL currently. Another set of changes which I am planning to bring in is that all the functions which return option and value option going to be returning different versions of options, which current or new options going to be stack allocated, and I'm going to introduce the reference option if somebody wants it, or like I'm going to rather introduce the functions which will be converting to the F# core built-in option. I have some plans to introduce the different faster map and built-in map and set implementations. And in general, if you have any suggestions, if you have any kind of wishes, please list them in the issues. I kind of want this project to be maybe a testing bed for kind of F# core implementations for different data types, for different functionality, if the team decides to, once they, I'm going to talk about it a bit later, but if the team decides to introduce team or community will decide to introduce sort of layered F# core, or the ability for us to ship common F# core and then small additions per target framework or per minimal target framework. This can be a testing bed of figuring out whether certain things work or not, working or not, whether new map or set implementation, if they are correct, how do they behave under loads, how they how they are behaving at runtime, etc. So the project is very simple. It's just a library which I'm publishing to NuGet. I think I didn't publish the latest version, but there is at least one or two versions there. It's separated by the modules, have some prim types with, for example, here for now it's just a lock, which implements a lock for a new system threading lock, and a lock function for the just an object. So via the monitor enter and exit. There are modules for the array. This thing is, for now, it's kind of extensively covered by the tests. I have the tests both, let's see, for example, the max tests. I have the both corner cases tests and some property-based testing to make sure that all of them behaving the same way, like the old one, the new one, and the one which is I'm using, in this case, for example, enumerable max. I have a bunch of benchmarks already for the array. You can just build it and run it. It benchmarks creation and some some other functions I've been working on, or the things I'm using. So yeah, feel free to play with it. Tell me what's wrong. We can talk about it. But my intentions with this package, I really want to kind of try to experiment with better defaults for the core library, or for the prelude library for the F#, meaning by better defaults, meaning that more JIT friendly, more memory friendly for the .NET runtime. So now some kind of historical reasons besides that, F# core has to be a maximum compatibility, is that we, and even before me in the team, and I'm pretty sure after me, there are and will be numerous attempts to kind of improve the situation in the F# core itself. And for those who don't know, F# core is kind of special library because compiler knows about it. We always carry implicit copy of the F# core, despite what you can be using the one from NuGet, the older one, the newer one, but F# compiler or SDK always has the F# core which it can use. So the problem is that F# a bunch of F# core types and modules are implicitly opened by the compiler when it generates the resulting assembly. So, and that's why it's special. F# libraries also carry a couple of resources for inlining, for the optimization, which makes separating the library into multiple libraries not as easy as we wanted to, and which also involves a bunch of type shadowing, or we need to, for example, to know how to shadow, if we were to separate the F# core to the base library and then a bunch of independently shipped libraries for specific platform or specific target framework which our users targeting, we would have to solve the problem of compiler and F# builds, which is the set of targets and set of properties for the MS build, for it to figure out in which order and which DLLs needs to be loaded and how they should be opened in order for to make the proper, not only proper shadowing for the user and in IDE scenarios, but also for the proper for it to figure out which resource it has to use to properly inline certain things, because those are kind of not part typical assembly, but a part of the resources. So I suppose the third-party library was the easiest way. If anyone has any ideas how the F# core itself can be separated, I think the proposal can be always written to the FSLang design, and we can discuss it. But it's shown to be not easy. So, are there any questions, or does anyone want to discuss something? I'll be happy to answer.
I think maybe to explain the term vectorization could be worthwhile for some of our watchers.
Right. So when we do, or .NET, well, not only .NET runtime, but pretty much any language, whether it's JIT or ahead of time compilation, when you work with something you loop over some data. In certain cases, if the architecture supports it, you can loop not one by one, but you can loop. You can use specific instructions which will be processing the data in bulks. If it's kind of very, very primitive explanation, if you will. I think Arseny is here. If he wants to chime in and explain it more, I'm happy to, or in the chat. But it's pretty much just we process more data at once.
Hello, everyone. Privileged to be here. Can you hear me?
Yeah.
Excellent. So yeah, as Vlad noted, vectorization is modern CPUs usually offer basically modern CPUs on top of being quote unquote super scalars, meaning that they can have a multiple arithmetic logic units which execute your arithmetic operation. So when you add A plus B, and they can do a bunch of these per cycle, but that's not enough, and that's a lot of work. So since a long time ago in computer science, everyone realized that obviously if you have a lot of repeated common operations, you can just put things in a vector and apply a single transform operation, either unary, binary, or whatever, and do many things. Single instruction, multiple data, which means that, and .NET over the recent years has massively improved its capabilities. As of today, it's probably one of the best platforms to write portable CMD code. Obviously, we have the behemoths, C, C++, and now Rust, and even newer languages like Zeek, that and anything that is based on LLVM that can do this very well. But .NET is it's sort of a wild card because because it's much better at providing higher level API, and it slots really nicely in F# as a language, because in F# as a language you can define operators and just generalize over primitives, and then you can have just numeric code which just knows that you can add things together and not even bother whether they are integers, whether they are scalars and vectors. And because these primitives usually structs, it nicely monomorphizes in runtime, turns into this zero cost abstraction, and It's a pleasure to work with. There are some, and this is hopefully maybe I get to have time in the future to contribute to this library. It would be nice to have maybe F# first, like tspan alias, so it's just nicer to work with spans. But yeah, vectorization is really important, and it's really, as you can see on this code, like in languages like, I know, Vlad, you're working on C++ backend, but in languages like C++, doing this it's kind of a pain, because you have to either import bespoke platform intrinsics and just write for Intel and then for ARM64, and it's a lot of code. And here you just try. C++ has this CMD vector that is going to be a thing in the future, but still, it's just not as nice as with JIT, which can look at the exact CMD instruction set supported by your CPU and make the best use of it. And all of that is possible with this quite simple loop. And let me like take a look at it. And it's safe code. It's safe code. There is no unsafe here. It's bounds checked. So, and just load like 4 integers in a vector and do it with like latency of single or 2 cycles, addition of them. And if you're summing something like byte, it's massively faster, because if you have vector 128, instead of doing like 16 loop iterations to sum, let's say 16 bytes, you just do it once, and it's so much faster. And I know Rujit is not perfect, and it has weaknesses, and is more constrained in computation budget when it compiles code. But such a convenient way to vectorize code with the best available instructions is one of the key areas where .NET as a platform, it regains performance gap with like LT compiled languages, which may not be able to as best to take advantage of this. So through different means, nowadays it is able to match quite confidently in way more scenarios than it used to. Yeah, thank you.
Thanks. Yeah. So this is this is the proper explanation, but from me it's that you can process data faster, like especially on the operations like doing the sum, searching for the max and things like that. So a bunch of so in the F# core there are multiple ways to achieve that. One of them is to use what BCL provides to you, like the current BCL, which you're loaded at runtime and like calling via, for example, enumerable max. And another way is to write this code yourself, and that's both have downsides. First one, or upsides and downsides. First one is that like if you use the BCL, you can be sure that it's always using the best or most optimized implementations provided by your runtime. And as Arseny mentioned, one of the benefits is that JIT will choose instruction, like it will choose to use the most optimal things provided by whatever CPU you're using currently on your machine, whether it's ARM, Intel CPUs, AMD CPUs, something else. The downside of that, it will have to be at the compile time of the F# core. It will have to be in the BCL you're using, and we're coming back to the issue of do we multiply the TFMs or do we layer the standard library properly, which is hard. And this is like why this guy exists, which we for your current platform you can just reference it as a NuGet package and shadow everything else. The second one is you write code by hand. Actually, I don't exactly remember why I wrote this one by hand. I had some issues with enumerable sum, and probably the issues around that it's not generic. It has a bunch of overloads. I'm not sure. Like I will need to check. And So, but then, like, you won't be having, you will sometimes need to maybe revisit the code if the BCL or runtime introduced some other intrinsics or like as part of BCL, some other better way of, working with vectors, or like working with data you want to vectorize. Sorry, it was long. I hope I answered your question, Dave.
Yep, thanks.
It looks like we do have 2 questions. I'll go with the first one. People are getting a 500 on the NuGet package website.
Oh, yes. So, sorry about that. And I talked to the NuGet team already, and I will fix it. The previous README contains the perf details, like the table from the benchmark.net, and NuGet parser couldn't handle it, and it was just erroring out. They asked me to remove it. I think I lost my cursor. Yeah, I think I did remove it, but I didn't upload the NuGet package. I will do that. Yeah, so I did remove it, and yeah, I don't. They decided not to fix it. Apparently, I do not really know why. Yeah, so this one was. Yeah, so a bunch of benchmark
Did you
data.
move that? Did you move the benchmark data anywhere, or is it just
No,
in the
but
past?
I can add it to the I can just add it to the work tree and push it. So because
Yeah.
like it's just a matter of just running this guy, and it's going to generate a GitHub Markdown. So I will push it, but I encourage you to, like, if you're interested, I encourage you just to clone the repo and .NET build it and .NET run the benchmark. It's I don't use here like any fancy build scripts or arcade or whatever the nonsense .NET repos are using.
Right,
Is there
cool.
any good way of knowing whether adding this NuGet package will have effect on your own code base? Because not everything, of course, has been rewritten, revisited. How do I know if this is for me or not?
Well, good question. So for now, it's just like, hey, are you using like a bunch of, like, are you crunching a bunch of numbers? If yes, on arrays, for example, right? If yes, then yeah. Like once I add the map and set, it's like, are you utilizing them? If yes, then you will see benefit. Or things like, if you in the current state, right? Like if you're using locking a lot, it's going to probably help you on the modern runtimes, because it's using the system.lock or system.lock. I think the new object, which is much more friendly to the well, it's better. So I'm planning to just go through a bunch of core library stuff and just experiment with it, including that, like, hey, we now, like, all the try functions, we now going to return value options, right, instead of options. Again, drop-in replacement might require you to change a bit of your code, especially like if you do the converting from options to something else, or like matching with some and none. I have some ideas how to make it much less painful. It's not going to be like, unfortunately, it's not going to be just implicit or explicit casting, because, of course, F# compiler has special cased F# option, and it cannot be implicitly cast to anything else, and anything else cannot be implicitly cast to it for reasons. And I have few ideas how to ease the pain, and then like pretty much kind of a bunch of generic code which are using, or general code which are using and using options, can be probably improved. But that's a good idea. I would need to think about it, how if there is an easy way to assess whether you will benefit from it. Maybe we can do some analyze what your project is using, and then trying to outline that, like, oh yeah, like a bunch of optimized functions now will be used. So that's good. Thanks.
Oh, just
So-
for our benefit, would you mind showing the benchmarks that you had previously? Let's just go back a couple commits and just see it, just so people can see how much faster things are, at least on your machine.
Yeah, give me a sec. I can just. Well, it's gonna take a while to run it, and I'm on a battery. So
Yeah, I would say you don't want to run it. I just want to see if we can at least show off what they were, just so people get an
let
idea
me
of how
actually
much faster.
see whether I cleaned up the repo since I ran it last time or not. Oh, I didn't.
We can probably just look at the file before you removed it and show it in the browser.
But
Yeah.
I added a bunch of stuff since then.
Oh, I see.
So let's see. Joins. Give me a sec.
For simple operations like this one, it's usually at least how many elements can fit in a vector. So if you have vector 128, as Vlad is using a Mac, then you can at least expect 4 times speed up. I mean, it depends, especially if like it's a short length and there is some baseline cost you need to pay. If you have a vectorized loop, you need to do a little bit of like juggling data to set up working with the core vectorized part that works on vector, and then handle the tail, like all the elements that didn't fit in the vector.
So let's see. So min-maxing, I guess that were the only ones I implemented. So this is, so for example, the maxing of in 32s before was what is it, 30? Wait, it's only 1,000. It's not interesting. Let's go with what is it, 2 million. We have 60 million nanoseconds versus 300,000 nanoseconds processing the 2 million in 32s by maxing it. So it's kind of, well, yeah, max is a bit special. I can agree. We also have some Winson allocations. We don't allocate in majority of the cases anymore when we do like some numerical stuff. Let me see if I can find the sum, for example. Array. I don't. Hold on. Benchmarks. Hold on. No, it didn't save it, but I can just run it after we, after I'm on the power and just commit it to the repo and share the link, like on a Discord, for example, or like even on the page of the amplifying F# if we're fine with the sort of kind of modifying the meeting.
Yeah, that'd be great.
Because I'm iterating on it quite often, and like I have a few uncommitted changes, but in 100% of the cases I so far introduced for like my own things, it's quite a big difference, and we almost always going to be eliminating the majority of the allocations and is going to be a bunch faster. From my map and set changes, it's the footprint is much like the memory footprint was going to be much lower, and insertions is a bunch faster. I'm sorry that I cannot come up with specific numbers. It was interesting week at Microsoft, and I didn't exactly had time to prepare like something new and something more exciting. But I'm gonna push the change to the repo over the weekend.
So I guess if you want to use this in like a .NET tool, this is a no-brainer, right? Like if you're not
Yes.
sharing this as library or anything, if it's just a tool.
Yes, and I think I can easily make it conditionally depend on the F# core itself, because it uses only very few things from F# core. So it's going to be only needing it at runtime, and it's going to be loading whatever you have, and because it only will need types pretty much, or like type aliases, doesn't use a lot of things. It uses very generic stuff like raising exceptions if something is wrong, or like unit type, some type aliases like int instead of int32. Use things like that, or like uncheck default of, which can easily be part of the library itself.
Yeah, it's
Any
cool.
any
You're
ideas
gonna
perhaps what we can explore, or like can maybe people in the chat, or people who are watching, maybe they have some pain points which are like, oh, I wish F# core did X, or I wish F# core did Y.
Well, I was thinking of just giving this a shot in Phantomus, see if that speeds anything up of all the things we do.
That would be also interesting. I would like to take a look at the Phantomus and see like what's the most common thing it's working with, and see if we can, just by dropping in some different implementation, if we can just have a easy win.
Yeah, should definitely follow up on that.
Yeah, we can have a bunch of aliases. That's for sure. I can play with it. If you can create an issue, I will look at it. There are a couple of existing issues which are make string interpolation different or handled differently. This is arguably it's a bit more opinionated. I'm like we can try and test it, and have an opinion from the community. There's some which are very specific ones, like the replacing operator with a different implementation. I'm personally fine with it if people think that it's better default, and things like the try trying to fix try functions, or like rather the non-try variants to return something like result or value option by default, because it was always weird to me when in languages like Haskell or F#, when you destructure something or use had instead, it just like throws, as opposed to more of a Rust approach when you have a like or else, or like or throw variant of the function. I personally think it's opinionated, but I tend to agree that it's kind of a better default. So I'm also open to explore that. I'm not, with this library, I'm not saying like, hey, go everyone, download it, use it, and whatnot. Just, Florian offered me to kind of share things about the library. I'm using it myself in a couple of projects, like the personal projects or like non-Microsoft related projects, and I'm adding things there as I use it, and then I kind of backport it to this NuGet package, and I just maybe there is a kind of cheaper. This could be a cheaper way of having different same defaults for the core library without actually like trying to break core library, because nobody for some reason wants to touch F# core in the sense that like try to fix it, because it's it's a big chunk of work.
All right. Any other questions to people online? So
There was a question via Discord. I will just repeat it. Is it going to offer a C# friendly API as well?
I don't see why not. I mean, like, by friendly, like, I would like to see examples of like what's kind of APIs the person has in mind. Like, I again don't see why not, because a bunch of stuff apart from types and functionality around optional types, different optional types. This kind of wraps C# functionality, like the vectorized implementations, for example. So it's kind of, in many cases, C# would already have many of those. If we're talking about, for example, if you want to use the map of F# in the C#, I don't see why not. It can be a module or type with a bunch of methods, which will be supporting deconstruction for the C# and or ref read only, you name it. So yeah, sure, I'm pretty open at that. But again, like, I don't want to be. I want to be using this library myself. I don't want to be in any case or form a PDFL for that. And like, I will be happy if people who know what they want from better defaults, if they chime in and we can figure stuff together.
all right, I think those were all the questions. So thanks again, Vlad, for having this session. This is very eye-opening, and I'm definitely encouraged to give this a shot now in my projects. Very curious to see what this actually does. I would recommend other people just do the same, open issues, talk to each other, and that's how we sort of shape this project, I suppose. I guess some parting words from my end. There is a new .NET release, so 9.300 came out a couple of days ago. Also, please give that a shot so that the team knows if there are no regressions or if anything still works out perfectly fine. Because I would say that that SDK also has some bits related to .NET 10, I suppose. So it's always good to stay on top of that. And even if you're sticking to .NET 8 LTS, just give 9.300 a shot as well. I think the team will be appreciative of that.
I wanted to mention one thing is the .NET team has been working hard on a feature called, so they changed the name, a bunch of stuff, but it's essentially a virtual monorepo, which is located at github.com/.net/.net. Very surprising name. And it's pretty much a virtual monorepo. So it like pulls all the .NET together, and it sits in a one repo. And if you somebody who is watching it or like now online, you can just go there and build the whole .NET from one repo, and it's going to build runtime, C#, F#, MS build probably. We should ask chat about that, but should build everything. So it's like means to replace source build, and contributions go both way. So if you want to make an improvement like to everything, like runtime and F# compiler and Roslyn, and on something, you can go there and make this change, and it's going to sync it to the corresponding repo. Just decided to mention if somebody wants to tinker with .NET, like with the latest bleeding edge main of everything, you can just go there and build it with the one script, and it should work.
Those are interesting. So if I have a small little issue in F#, I can like send a PR, do an entire .NET build, and then test the SDK out on my local machine. Is that possible?
Yes, it is possible, definitely. Yes, you don't have to, because if you want to fix specific like F# issue, you can still go to the F# repo, make a pull request, and it's just it flows both ways. So, and it flows to the .NET, and then if you make a change in like this repo, it flows back to F#. So, but like if you want to like test something like complex, and you think that maybe BCL had a regression, then you just can go there. And you can even go as far as you can roll back the BCL on a certain, the states, and then like build it and then see if it still regressing or not.
Got it. All right. So thank you very much, Vlad. Thank you everybody else for joining, and we should be back next week with another exciting episode.